Okay. So now we know about voltage, we need to learn about resistance and how it affects electrical circuits. So let's go back to the water analogy. We have a 5mm diameter straw, we have a 1mm diameter straw, and we apply a certain amount of water. Say like 1 litre to the top of this straw, 1 litre to the top of this straw. Which straw is going to drain the water quicker? It's a bit of a no-brainer, right? Obviously the one with the larger diameter is going to drain it much quicker. If this is 5mm and this is 1mm diameter, this is going to drain it 5 times as quick, right? And how does that apply to resistance? Well, effectively, which one has the least resistance? What is resistance? It's trying to stop the work from happening, right? So using that analogy, this is going to have higher resistance because it's taking longer to do the work, to drain the water. This is going to have 5 times more resistance than this is, right? Because this is 5 times smaller. Simple. Simples.
Simples.
So let's apply that to an electrical circuit now. We have a little simulator here. We have 5 volt supply. We have a 1 ohm resistor. We have a multimeter measuring the potential across the resistor. And here you can tell that it shows that the current flowing through this wire, through this resistor, is 4 amps. And that's because of Ohm's law, right? I equals V on R. So if we have 4 volts on top of 1 R, 1 ohm, 4 and 1 is 4, right? So we're going to get 4 amps of current flowing through that wire. Now, we have this little apparatus here. And what that is resistance wire. It's nichrome resistance wire. I measured this before, and approximately the resistance across this wire from here to here is about 1 volt. No, it's changing a bit. 1.6, 1.4, it's going down. If we hold it on there, it'll drop down to about 0.9, but between that 0.9 and 1.2. So I'm just going to say this is 1 ohm resistance from here to here. Therefore, if we apply a 4 volt supply to that, how much current are we going to get flowing through this wire? Well, it's the exact same circuit as the one simulated, right? So we should get 4 amps of current flow. Attach this wire here. We have our 4 volt supply, which is the 18650 cell, not fully charged, so it's 4 volts from the previous video, and we attach this here, and that's fucking hot. So there's current flowing through that. If we drop it halfway, that means the resistance is halved, right? Because the potential between here and here is still 4 volts, but the resistance is not 1 volt anymore. It's not 1 volt, not 1 ohm, it's half an ohm, right? So 500 milliohms. 4 on 0.5 is 8, so we should get 8 amps of current flowing through this. Not too good for the cell, but it's only for a little while, so it should be fine. Okay, you can see that starting to glow, right? That's red, that's hot. If we go a quarter, that's about 250 milliohms. So therefore we should be getting about 16 amps, which is very bad for the cell, but it's only for a burst, so it should be fine. Now watch how quick this lights up. See that? See how quick that glowed? Look at that. The shorter we go, the quicker it'll do it. This will be instant whiz. Longer. Just gets longer to glow. See it slowly move out there. As we move it along. More resistance means less current. High current, lots of brightness. Takes longer, right? And as we increase the resistance, the current decreases. So that's basically how resistance affects circuits. The more resistance, the less current will flow, and it's proportional. Ohm's law, I equals V on R, or V equals I times R. And that's basically it. Now current, what is current? Using the water analogy, we have the straws again. If we have the 5mm straw, the 5mm straw and the 1mm diameter straw, and we apply the 1 liter of water again to the top of each straw, this one's obviously going to drain it quicker, 5 times as quick. And that means 5 times as much current is flowing through this straw than this straw. That's basically current. I equals V on R. So if we have V of 4 volts between this point here, this and this, and we have R of 1 ohm, the diameter of the straw, we're going to get 4 amps of current flowing through. If we widen the straw, right, we're effectively decreasing the resistance. So we're decreasing the resistance along here. This is the full straw, but if we move it along like that, the straw effectively opens up, allowing more water to flow. That basically increases the current, right? That's it. That's resistance, and that's current. I equals V on R, Ohm's law. It's not too scary.